Hello students, welcome to Narayan PU online classes. So in the last video, we have discussed about the electrophilic aromatic substitution reactions. So I have given a small introduction about that. And you know that whenever the OH group is present on the benzene ring, it activates benzene ring at mainly ortho and para positions. So that's why electrophilic substitution reaction takes place mainly at ortho and para positions. Okay? So now we will discuss some reactions. First one is here nitration. First one here nitration. So electrophilic, you have studied already in the first year. Electrophilic substitution reactions of benzene. So what you have studied in that one, you know, electrophilic substitution reaction of benzene, mainly chlorination, nitration, sulfonation. Okay? So that's one only we will discuss here. The first one is nitration, but there we have discussed about the benzene. Now here phenol. So what is this one? First one, whenever we take the phenol and is treated with the dilute HNO3. Dilute HNO3. Yeah? Dilute HNO3. You know what is the electrophile here? NO2 plus. Electrophile here in this case is electrophile. Electrophile is NO2 plus. This is the electrophile. Yeah? So then what the reaction takes place? You know that which type of reaction here? OH activates the ortho and para position. So that's why you know NO2 group, that electrophile will be added, substituted at the ortho position, and the second one is here at para position. It is at para position. Clear? So what is this compound name? This is orthonitrophenol. This is orthonitrophenol, and this one is para nitrophenol. Orthonitrophenol and para-nitrophenol. So with dilute HNO3, we need not to use here any, Lewis acid catalyst here. And benzene we have discussed. Whenever we take the benzene and chlorine and FeCl3, LCl3 we have taken. So it increases the rate of reaction and it increases the rate of reaction. But here we need not to take any Lewis acid catalyst. Why? Because OH it activates the benzene ring very large extent, means it activates the benzene ring very high. So that's why you need not to take any catalyst here. So directly, means here one is orthonitrophenol and the second one is para-nitrophenol. Yeah. So now these two compounds are separated by steam distillation. Very important here. These two compounds are separated by steam distillation. Steam distillation. Yeah. So how we will separate these two compounds as steam distillation means, if you take the first compound, orthonitrophenol is a volatile compound. Which compound here? Volatile. So here OH and NO2. So here double bond O and O minus, and here nitrogen having charge, plus charge. So here this compound, it is a volatile compound. Why? Because it forms intramolecular hydrogen bonding with the NO2. It forms here, this is a volatile compound. This is a which compound? Volatile compound. It is a volatile compound and it forms, which one here? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding, orthonitrophenol is a volatile compound. If you take the para-nitrophenol is a non-volatile compound. This is benzene, and here OH, and here I will write NO2 group, and this is a non-volatile compound. Non-volatile compound. Why it is a non-volatile compound? Because it forms a intramolecular hydrogen bonding. If I take here another nitrophenol, and NO minus and double bond O and plus, and here OH, and same another molecule if I take here, same N double bond NO minus and double bond O and positive and OH. Keep on writing like this. Then you see this is a hydrogen bonding and this is a hydrogen bonding. Means more number of the molecules are associated and forms here, you know, intermolecular hydrogen bonding. Intermolecular hydrogen bond. So in intermolecular hydrogen bond and so many nitrophenols, para-nitrophenol molecules are associated together. So that's why it is a non-volatile. But here there is only one compound and in this one OH and OH and O and forms a hydrogen bonding intramolecular hydrogen. Only one molecule is there. So it is a volatile compound. So it is a volatile, it is a non-volatile. Clear? Because here so many hydrogen bonds are there. Whenever hydrogen bonds are more, then the molecules are come very close to each other. So that's why, and they cannot form vapors easily. So non-volatile. It is volatile. So that's why if one is volatile and another one is non-volatile, then those are separated by the steam distillation. Clear? So this is the nitration. With which one here? Dilute HNO. Clear? And the second one. And with concentrate HNO3. If you take here concentrate HNO3. If you take the concentrate HNO3, you know here it is a phenol. Phenol is highly reactive and also I have taken here very concentrate HNO3 here. So then what will happen? It is very reactive and it is also very reactive. So that's why, and here total ortho and para positions are substituted by, you know, nitro group. Here which one here? NO2. So what is the name of this compound? 2,4,6 trinitrophenol. Trinitrophenol can also be called as this is picric acid. Can also be called as which one here? Picric acid. Clear? But and nowadays picric acid is not synthesized by using this method. Why? Because means, you know, concentrate HNO3 is a very good oxidizing agent, also strong oxidizing agent. And you know, oxygen, this OH of oxygen, it gives the electrons to benzene ring and benzene ring get activated highly. So that's why what will happen? Here it can act as an oxidizing agent. So that's why some of the phenol are oxidized by the concentrate HNO3 and remaining phenol is converted into 2,4,6 trinitrophenol. You will get the very less yield of the product. Then how to prepare the, and here for picric acid in a good yield that they have given in the NCERT textbook also. Yeah? So how to do this one is, and we will discuss later because first we will do the sulfonation and after then we will go for the picric acid, how to prepare in a good yield that we will discuss. Now next concept is sulfonation. Next concept is which one here? Sulfonation. Clear? Sulfonation means you already know here. Same, I will take the and OH here, phenol, and now treated with the concentrate H2SO4. When I treated with the concentrate H2SO4, you know, you will get the compounds at the ortho position and para position. You will get here compounds. Clear? One is at ortho position and another one is at para position. Clear? So it is what we can write here: ortho hydroxybenzoic acid, para hydroxy benzoic. Para hydroxy. This is, you know, ortho hydroxy benzene sulfonic acid, and here para hydroxy benzene sulfonic acid. So here these two are obtained here, but you know this reaction depends upon temperature. This reaction what it is depend upon temperature. Suppose if I take first one is here phenol, take the phenol and do the and concentrate H2SO4 and maintain low temperature at 25 degrees centigrade. At 25 degrees centigrade, you will get the compound is here ortho product. Ortho product is the major one. This is which one here? Major one. If I take here same, if I do the sulfonation, if I concentrate H2SO4, take the 100 degrees centigrade. then you will get the compound is here para hydroxy benzene sulfonic acid. Clear? So this is why means, you know, we have taken here temperature is less. When temperature is less, you know, here what will happen? There will be hydrogen bond formation takes place here. What I can write? Double bond O, OH here. There is a chance of hydrogen bond formation. So that's why due to this hydrogen bond formation it is more stable. Because extra bond is coming means the compound is stable. So that's why that is major product. If you take at 100 degrees centigrade, suppose at 100 degrees centigrade just assume ortho is major. Then temperature we maintained very high. So that's why this hydrogen bond breaks. Hydrogen bond breaks means this compound will not form. Because why if it forms? If it forms hydrogen bond, it is stable. But at a high temperature, this hydrogen bond breaks. So that's why ortho product is not major. So that's why which product is major here? Para product is a major. So that's why this is what it is, sulfonation. Now we have discussed about the nitration and sulfonation, and just now only I mentioned here picric acid preparation, and we prepared picric acid from the phenol treated with the concentrate HNO3. But I already mentioned this concentrate HNO3, it is a strong oxidizing agent. Some of the phenol is get oxidized, and very means remaining phenol only forms the picric acid, so you will get the very less amount of the yield. So that's why. So what is the another method to prepare the picric acid is, so first we will take the phenol here and do the sulfonation. What you have to do the sulfonation. Sulfonation means, and here take the concentrate H2SO4 here. And you know concentrate H2SO4 means at ortho position and para position sulfonation takes place. I will write these two together only. Means one is SO3H and at para position there is a SO3H. This is the molecule. Now you see. Previous, this benzene ring is highly get activated by the donation of electrons of oxygen of OH group. This OH group donate the electrons to benzene ring. So benzene ring is highly get activated. So it easily undergo oxidation with the HNO3. But now what we did here, we did sulfonation. And here at ortho position and para position SO3H groups are present. So these groups are, you know, highly electron withdrawing groups. Whenever electron withdrawing groups are present on the benzene ring, they decreases the electron density on the benzene ring, and you can say these electron withdrawing group deactivates the benzene ring. Whenever they deactivate the benzene ring now here in the phenol, it is active means the phenol benzene ring activity somewhat decreases. When it decreases, then we will treat this one with the concentrate HNO3. We will treat this one with the concentrate HNO3. Now benzene ring is not highly activated, so that's why it won't be oxidized by concentrate HNO3. Clear? And you know these SO3 groups are very good leaving groups also. So that's why here what happened, nitration and desulfonation takes place. Desulfonation. Clear? Why? Because SO3H groups are very good leaving groups. So that's why what happened here, and you will get the compound is and OH and here NO2 and here NO2 and here you will get the NO2. So that's why what happened here, you are getting picric acid. So this is, you will get in high yield. You will get the compound here in high yield. Clear? So this is the picric acid preparation. It is there in your NCERT textbook. They have not given here in the form of equations. They have given first phenol has to phenol should undergo sulfonation, after that concentrate HNO3 nitration, then we will get the picric acid in high yield. They have given. We have framed that one in the form of equations. Clear? And the next one is here bromination. Next one here bromination. And the nitration completed. sulfonation completed, and now bromination. Now you know that in phenol, first of all, what we will do, we will take the phenol and take the bromine in non-polar solvents like carbon disulfide. Clear? Then we will get the compound is monosubstituted compound, that is orthobromophenol plus parabromophenol. You know, this is a monosubstituted phenol, you will get it. Clear? And if you take the same compound here, OH, and treat this one with the bromine water. What you have to do here? Bromine water. Take the bromine and plus water. Bromine water will become. So in this case, you will get the compound is OH and here Br and Br. Tri-substituted phenols you will get. You will get here 2, 4, 6 tribromo phenol. You will get tribromo phenol. Okay? So here non-polar solvent, here polar solvent. In non-polar solvent, monosubstituted phenols you will get. In the polar solvent, you will get the tribromo phenol, tri-substituted phenols. Why? What is the reason for this? Simple. You know what is a polar? And you know phenol is a polar compound, so that's why polar molecule dissolves in polar solvents. When it dissolves, phenol is get ionized. When phenol is get ionized, you know what is the product you will get here? You will get the product is O minus and H plus. It dissolves in water and converted into ions. You know here what you are getting? Phenoxide ion. Phenoxide ion. It donates the electrons to benzene ring in a large extent, and activates all the ortho and para positions. It activates highly ortho and para positions, so that's why and tri-substituted product you will get it. But here non-polar solvent means it won't be ionized. It won't be ionized, it means you already know, and it activates, it gives the electron, it releases the oxygen, releases the electrons to benzene ring in a small extent. So that's why you will get the monobromo product. Yeah? So this is about the which one here? Bromination. Very, very important. This reaction most of the time they are asking in the PU examination. So you have to remember this. Clear? So this is the about bromination. Yeah. So now we have discussed about the bromination, and you know one is orthobromophenol, second one is parabromophenol. Which one is major product? You know here major product is parabromophenol compared to orthobromophenol. Why? Because here these two groups are very close to each other. When they are very close to each other, then there will be a repulsions. Because this molecule are also having electrons, and this bromine is having also 3 lone pair of electrons, oxygen is having 2 lone pair of electrons. So when they are very coming to close each other, then there will be electron-electron repulsions. So this ortho is always minor product in this case. This is a minor product. Okay? So this is about the, you will remember very important, this is CS2 means monobromo product. And polar solvent H2O means you will get tribromophenol. Clear? Reason I have mentioned. And OH is converted to O minus. O minus means it donates the oxygen, donates the electrons to benzene ring in large extent, and so that's why this benzene ring is highly activated. But here, compared to here oxygen also gives the electrons to benzene ring, but small extent. When it is giving small extent and it is slightly activated, so that's why you will get the bromo product. And next one is write the structure of major products of this. This is from the NCERT textbook. If you see, this is 11.5. Example, it is there 11.5. Clear? So they have given here, write the major products. Mononitration of 3-methylphenol. What is the 3-methylphenol? This is 3-methylphenol. OH and there is a CH3. Clear? Now what you have to do? Nitration. Mononitration you have to do. Mononitration means where the products you will get it. You will get the where the NO2 group will be added. Very important here. Both are donating groups only. OH and CH3 both are donating groups, but you know, and OH is highly electron donating group compared to the CH3. Powerful donating group, powerful electron donating group. OH is a powerful electron donating group compared to the CH3. So that's why nitration takes place according to the OH. So you will get the compound is first one to the OH ortho position. So here CH3 is there. This is also ortho position. This is also ortho position. You have to add the NO2 group here. Why? Because if you add NO2 group here and 1, 2, 3, because here NO2 group is there will be repulsions between the OH and CH3 unstable. So you have to write this side. Another possibility is what? You have the another possibility at para position. Para position means what is the para position here? And this is the para position. To which one? OH. Clear? So whenever there are two electron donating groups are there on the benzene ring, so which one directs the incoming group means which is highly electron donating. So that's why OH is highly electron donating. So to the OH ortho position and to the OH para position you will get the compounds. Dehydration you have to do. Means two NO2 groups should be added. Dehydration means how many groups should be added here? Two NO2 groups should be added. So which one is the major product? And here two nitro group means with respect to which group it should be added at ortho position? OH, not the CH3. So that's why here you will get the NO2 and another para position NO2 dinitro. Clear? Because here also ortho position, but due to the repulsions we should not carry here. So we have to add NO2 group this side. And next one, mononitration of phenyl methionate. This is phenyl methionate. So this is COCH3. This is phenyl methionate. Yeah? Yes, sir, this is CH3COOR. So first phenyl methionate. Clear? So this is the compound they have given here. So first you have to do the mononitration. Do the mononitration means one NO2 group should be added. And where it will be added, you know, this is the oxygen. Oxygen is added here. Electron donating group. Electron donating group means it activates the ortho and para position. NO2 group should be added at ortho R para. But which one is the major? You will get one is major product you have to write OCH3. Major product means which one you have to write? NO2. Because if I add at ortho position, this is a bulky group and NO2 is also bulky group and there will be a repulsion. So you will get this is the major product. Important, sometimes they are asking in the examination. So this is about the. So next one is here coal-based reaction. Very important for your PU examination. So coal-based reaction. So it is frequently asking in the PU examination. Yeah. So what is coal-based reaction? The conversion of phenol into salicylic acid. The conversion of phenol into salicylic acid. In this coal-based reaction, phenols are converted into salicylic acids. How phenol will be converted means we will discuss here. And first we will take the phenol. This is the phenol. Yeah. On the benzene ring OH group is there phenol. Now first it is treated with the base NaOH. Treated with which one base? You know phenol is a acidic and NaOH is a base and acid. You will get the salt plus water. Here H and here OH will be removed and you will get the minus H2O will be removed here and you will get the compound is phenol. This is the compound. So phenoxide, sodium phenoxide. This is. Yeah, or you can write according to the MCL textbook they have given like minus and Na plus. This is. So otherwise you can put the bond between the oxygen and sodium bonds, no problem. Yeah, this will be called as sodium phenoxide. This will be called as what it is? Sodium phenoxide. Now this sodium phenoxide is treated with the carbon dioxide and followed by the hydrolysis. So carbon dioxide is a electrophile here. Yeah. So what is the carbon dioxide formula? C double bond O and C double bond O. Clear? And followed by, this is the first step, and the second step you have to do the hydrolysis, acid hydrolysis. Clear? So H plus they have given means it is a acid hydrolysis. Then what the compound you will get is here OH at ortho position COOH. So this we will call as salicylic acid. Salicylic acid. Clear? So this is conversion of phenol into salicylic acid by using carbon dioxide as a electrophile called as a Kolbe's reaction. So how this it will form? Just I will not. You have to write this one only in the PU examination. Yeah. See here, simple mechanism how it will come means you know that this is a O minus and here C double bond O. C double bond O means you know carbon is more electronegative, carbon oxygen is more electronegative. It gets the partial negative charge, it gets the partial positive charge. You know this is Na plus. So this bond electrons comes here, this bond electrons go here. Then here the charge will get negative charge, and the negative charge attack at the positive charge. Then what the compound you will get? You will get the compound is here double bond O and here COO minus here plus N. This is. So next to do the hydrolysis here you know H will be come here and it will go. You will get the compound is OH present here and COONA. Next to do the hydrolysis H and OH again you will get NaOH. This is not required. Just I have mentioned how to form how salicylic acid is forming from phenol oxide ion. Carbon positive charge, and when it involves in the resonance, this carbon gets the negative charge, and negative charge attack at the positive charge. This bond will go towards oxygen. And again, to get the stability, this hydrogen bond breaks, and here OH will be shifted to the oxygen. You are getting? This is what it is. Kolbe's reaction, and a 2 marks question, very important for the PU examination. So next is Reimer-Tiemann reaction. Very important. Named reactions, all named reactions you have to remember. All named reactions you have to remember. Yeah. So in the Kolbe's reaction, phenol are converted into salicylic acid. Now in this one, salicylic acid, LIC, not C here, LIC, salicylic acid. Yeah. Now in the Reimer-Tiemann reaction, phenol is converted into salicylic. Here acid and here which one here? Salicylic. Yeah. And now what is the reaction? And first we will treat the phenol. Phenol is treated with the chloroform in presence of base. In presence of what it is? Base. Then it will be CHO group is introduced at the ortho position and followed by hydrolysis you will get the salicylic. So what the compound you will get CHCl3 and NaOH. Then you will get the compound is here. Base is there, acid is there. So it will be converted into salt Na plus and here you will get the compound is introduced the compound is here CHCl2. So I will just roughly say the mechanism, otherwise you will not understand. So this is at the ortho position CHCl2 will be added. Clear? And now after then you have to do the hydrolysis with the base NaOH. Clear? And when treated with the NaOH, then what the compound you will get is, and you will get the compound is and O minus and Na plus, and this will be converted into aldehyde. CHCl2 will be converted into aldehyde. Next ONA is there, and do the hydrolysis, add the water, and H will be added here, OH will be added here. You will get the compound is OH and CHO. This is salicylic. This is salicylic. So here what is the electrophile in the Kolbe's reaction? Carbon dioxide. And what is the electrophile in Reimer-Tiemann reaction? Very important here. The electrophile is CCl. What is the electrophile here? Electrophile is CCl2. So many times this question is asked in the examination. Examination not in the PU examination, it is in the competitive examination. So what is this one? This we will call as a dichlorocarbene. What is the compound here? Intermediate dichlorocarbene. Roughly I will say here. So how this one, it is not required to write in the PU examination, just for understanding purpose only. So this is for Reimer-Tiemann reaction. If they ask, you have to write from here to here. That is only. Clear? See now, chloroform we have taken. What is this compound? Cl and Cl. This is chloroform. This is chloroform. First it will react with the NaOH. Clear? NaOH is a base. Base what it will be to accept the proton. Then and the H plus will be removed. Then C minus will be there. And here three bulky groups are there, and the oxygen and the carbon there is a pair of electrons, so repulsions will be there. So that's why one of the unstable this is. So that's why one of the chlorine will be removed as a Cl minus and converted into, chlorine is removed as a Cl minus. This carbon gets the positive charge. Already carbon is having the charge negative, positive and negative. It will be neutralized. And here valence is 2, so carbon valence should be 4. So that's why it has the 2 free electrons to form another 2 bonds. That is. This will be called as a dichlorocarbene. And this dichlorocarbene now treated with the sodium phenoxide. First of all, sodium is there, phenol is converted into sodium phenoxide. This is. Now, it is a CCl2. CCl2 means, it is a electrophile, electron deficient compound. Because carbon should have the 8 bonds here, but here 6 electrons only there, electrophile. So what happens? Same reaction. Here, this bond electron carbon gets negative charge. This negative charge donates the electrons to carbon. So carbon is gaining electron, and then you will get the compound is here double bond O, and here there will be a 1 H, and here there is a H, and here C minus Cl2, because it is gaining electron from the benzene, so negative charge. Now what happened, you see, this hydrogen will be taken by this compound and it will be bond electron are shifted here, this bond electron will go there. Then what the compound you will get? You will get the compound is, and benzene ring again comes and minus, if minus is there, there will be a Na plus, and here what you will get? CHCl. That is the intermediate diameter. Yeah. Now you have to treat this one with the NaOH. NaOH means substitution reaction. 2 chlorine atoms will be substituted. Then what the compound you will get? O minus and Na plus and CH, OH and OH. 2 molecule of HCl will be removed here. And on the same carbon, if 2 OH groups are there, it is highly unstable because here repulsions will be there. So that's why to avoid that repulsions, 1 water molecule will be removed. 1 water molecule is removed, then what you will get here? You will get the compound is and phenol, phenoxide ion here, sodium phenoxide, and you will get the CH, and only oxygen is there and minus H2O, then you will get the compound is CH2, that is CH2. Then hydrolysis, H will be added here, OH will be added. This is. So this is about the what it is here. Reimer-Tiemann reaction. Simple mechanism, it is not required, and just how you will get the product, this is and this, I have roughly explained here. So previously we have discussed that reactions involving in the cleavage of CO bond. I mentioned mainly CO bond cleavage reactions are shown by alcohols. But only phenol will show CO bond cleavage reactions with zinc. I have mentioned that. So that is only now phenol with zinc test. This is also very important in the PU examination they are asking. Very easy. So what we have to do, take the phenol OH and treat this one with the zinc dust and heat it. Zinc dust and heat. Yeah. Then what happened here? You see, this bond breaks. CO bond, but it will not break easily, but in the presence of zinc and high temperature, and it breaks, CO bond breaks and will be converted into benzene and Zn. See here, H will be added to benzene ring and it converted into C6H5 and Zn. This is the simple phenol reaction with the zinc test. O will be taken by zinc, that is only. Next one is oxidation. Next one is oxidation. I already mentioned previous only oxidation with the HM3 I have mentioned oxidation reaction. So phenol, if you take the phenol OH, this OH group donate the electrons to benzene ring and benzene ring get activated, so involved in the reactions very fast. So that's why when you do the oxidation with strong oxidizing agents like potassium dichromate in acidic medium, it will be converted into benzoquinone. It will be converted into what it is here, benzoquinone. So remember here, it is not the benzene ring, and here positions you see, this is benzoquinone. Here double bond and here double bond. So this is about the benzoquinone. So these are the reactions of what is here, phenols. Clear? First reaction what we have discussed with the nitration. Next one is sulfonation, bromination, and the next one is coal-based reaction we have discussed, the ribothermal reaction we have discussed. Next one is some commercially important alcohols. So in that one, first one is methanol. What is the formula of methanol? Methanol. Here CH3OH. This is the formula of methanol. So methanol is well known as wood spirit. Wood spirit. It is well known as wood spirit. Why? Because it is obtained by a destructive distillation of wood. If you do the wood destructive distillation, and we will get the what is here, methanol. So that's why we will call, this is obtained by the wood, so that's why we will call this one as a wood spirit. Yeah, and nowadays, and this methanol is commercially prepared by the catalytic hydrogenation of carbon monoxide in presence of high temperature and pressure. Clear? So if you take how to prepare this is preparation, how to prepare this methanol means commercially how to prepare carbon monoxide is means catalytic hydrogenation of carbon monoxide by using here ZNO and Cr2O3 catalyst, and you have to maintain 200 to 300 atmospheric pressure, and also you have to maintain temperature and 573 Kelvin temperature to 673 Kelvin temperature. Then what happened? Take the 2 moles here, you will get the CH3OH. This is the preparation of methanol. Yeah? And this methanol is, it is very poisonous. Methanol is a poisonous. And injection of small quantity of methanol leads to the blindness. And while large quantity even sometimes leads to death also. Clear? So that's why, and these are mainly used. What is the main use of methanol is used as a solvent. Solvent in paints and varnishes, and sometimes it is used for the preparation of formaldehyde also. Yeah. So this is about the what it is here, methanol. And the second most important alcohol is ethanol. Ethanol. Clear? So this is the second one. Ethanol formula C2H5OH. And ethanol is mainly obtained by fermentation from the sugar. Clear? So what it is? It is obtained by fermentation of sugar. Fermentation of sugar. And sugar, and do the fermentation, then you will get the what it is here, ethanol. Sugar in molasses and sugar cane and fruits like grapes. Clear? And it is, suppose if I take here sugar, formula what it is, C12H22O11, and here hydrolysis means you have to do the fermentation in presence of N-wortase enzyme, then it will be converted into glucose and C6H12O6 plus C6H12O6. One is glucose and another one is fructose. This is glucose and fructose. Clear? So this is sugar, and you do the fermentation in presence of invertase, you will get the glucose and fructose. And this glucose and fructose C6H12O6 and will be converted into alcohol in presence of one enzyme zymase. Yeah, take the 2 moles here. Sorry, take the C6H12O6. You will get the C2H5OH plus CO2. Take the 2 moles. What you are getting here? Alcohol. So this is the clear. So now what it is? The main importance of this ethanol is used as a solvent. It is also mainly used as a solvent, and also it is used as a reactant, used as a main product to synthesize large number of organic compounds. Clear? Previously we have already discussed, from the alcohol we prepared here alkyl halide, from the alcohol we prepared here alkenes also by dehydration. This is starting material for the many of organic compound to synthesize. Clear? And also the commercially ethanol is cannot be used for drinking purpose. Why? Because means that commercially alcohol is will be poisoned by, you can say sometimes here, copper sulfate. So then what will happen? That and alcohol, when we add copper sulfate, the color of the alcohol will be changed. Yeah, and also sometimes you will use to add some pyridine, so you will get some smell. So that's why it is commercially prepared alcohol cannot be used for drinking purpose, and that we will call as a denaturation of alcohol. What we will call here? Denaturation of alcohol. Denaturation of alcohol. So this is the importance of commercially important of alcohol, that is methanol and ethanol. So here I mentioned here commercial ethanol made unfit for the drinking by mixing of copper sulfate and also pyridine. Pyridine if you add, and that alcohol gives very bad smell. So, and people avoid to drink that. So that's why, and that process we will call as a denaturation of alcohol. And another small concept is there here, rectified spirit, and sometimes they are asking in the competitive examinations. So what is the rectified spirit? Means it is a mixture of 95% of alcohols and 5% water. And absolute alcohol means there will be no water content, only 100% alcohol. And those alcohol we will call as the absolute alcohol. If 5% present in the alcohol, called as a rectified spirit. Next one is NCERT questions. Here this question is first one is 11.7 and this is 11.21. Yeah. See what the question they have asked here. Predict the major product of the acid catalyzed dehydration of alcohol. We have already discussed acid catalyzed dehydration of alcohol. Alcohols are dehydration, when alcohol undergoes dehydration and forms the alkanes. So here 1-methyl cyclohexanol. 1-methyl cyclohexanol. This is cyclohexanol, and first position there will be a CH3. And second one they have given butane 1-ol. Butane 1-ol means CH3, CH2, CH2, CH2OH. So you have to do the dehydration, then what the product you will get thereafter. Clear? Simple, in the dehydration, when alcohol undergoes dehydration, alkenes are the product. Whenever alkenes are the product, and which alkene is major product is decided by the Sage-Joff rule. We have already discussed. According to the Sage-Joff rule, and more substituted alkenes are always major products. Clear? So that's why if you do here dehydration of the first molecule, you see there will be a hydrogen here. Hydrogen always removed from the beta carbon in the dehydration. This is OH attached carbon is alpha carbon, and the next carbon we will consider as a beta carbon. We have two beta carbons. One is H, and here beta carbon. This is also beta carbon. Here also H is there. And I will write two possibilities here. And if you do here dehydration from this molecule, and here water molecule will be removed in this way. Yeah, this is the first one. Then what the compound you will get? You will get the compound is double bond here. there will be a CH3. If suppose and this H and OH is removed and double bond will form here double bond will form, there will be a CH3. There will be a CH3. This is. Yeah, you know which molecule is as a major product. They are asking major product. Major product according to the Sage-Gross rule. Highly substituted alkene always produced as a major product, formed as a major product. See here, this is alkene, and here H, and here there is no H. See, this is one substitute, and this is one substitute, and here there is another one substitute. So total how many substituents are there? 3, but hydrogen we never consider as a substitute. 3 substitutes are there. But here you see, this is a 1 and this is 1. How many are there? 2. And here how many are there? 3. So this is a major product. Here, come to the second one. Second one, you know what is the major product here. First of all, you know what is the intermediate formed in the dehydration. First of all, carbocation will be formed, OH first, H will be added here, protonation. In the second step, carbocation will be formed. Clear? And whenever carbocation is formed, you know it involved in the rearrangement to get the more stable carbocation. It is a primary, so that's why this one H will be shifted. 1 2 shift takes place here. Then what the compound you will get? CH3, and you will get compound here CH2, CH plus and CH3. And here now it is a previous here positive charge is there. This is alpha, this is beta, and this is beta. Clear? And if this beta hydrogen, now what will happen? Deprotonation. This is next one. Deprotonation, double bond will form here. So if it is double bond formed here, then what is the compound? CH3, CH double bond, CH3. If suppose and this beta hydrogen is shifted here, then what the product you will get in this case? You will get the product is, and here CH3, CH2, CH double bond, CH2. So which one is major product? This is because double bond carbon you see, one is alkyl group and another two alkyl group. And here if you see double bonded carbon, here hydrogens are there, and to this double bond carbon, one hydrogen, one alkyl group. So only one substrate. So which one is the major product? This is the major product. Come to here. Oxidation of primary alcohols to carboxylic acid. Primary alcohol I already mentioned. Oxidized to first aldehyde and after then acids. Directly acid means you have to use strong oxidizing agent like K2Cr2O7 and dilute H2SO4, or you can use KMnO4 also. Yeah, that is the first one. Now this is second one. Primary alcohols to and aldehyde means the reaction should be stopped at the aldehyde stage. Then I have given 3 main reagents here: CrO3, Collins reagent, and next one is PCC, or you can use PDC. Any one you can use. And you can put the best oxidizing agent is here PCC. Okay? And next one, bromination of phenol to 2,4,6 tribromophenol. This is the phenol. You have to convert this one. Just now only we have discussed. Converted it into, and here 2, 4, 6 tribromophenol. So what you have to take? Bromine in water. Take the bromine in water. 3 moles of bromine you take. You will get it. Next. Benzyl alcohol to benzoic acid. Benzyl alcohol. What is the formula of benzyl alcohol? CH2OH on the benzene ring. This group is benzylic carbon and this is benzylic alcohol. Should be converted into benzoic acid. See, same here. This is the primary alcohol. OH is attached to which one? CH2 group. It is a primary alcohol. Primary alcohol should be converted into acids. You have to use very strong oxidizing agents like K2Cr2, O7 or KMnO4. Next one, propanol to propene. Propanol to propene. Propanol to propanol, CH3 and OH and CH3. This is the 2-propanol. Propanol to which one? Propene. Propene means what it is? CH double bond, CH3. This is propene. So alcohol to alkene, dehydration. Dehydration means you see, it is a which one? Secondary alcohol. Secondary alcohol means what you have to use? 85% of H3PO4 you can use. I have already mentioned. Primary alcohols means and concentrate H2SO4. Secondary alcohol means you have to use 85% H3PO4 and 440 Kelvin. If tertiary alcohol, 25% H3PO4 and 358 Kelvin. I have already mentioned. Last one is here. Butane 2O and CH3 and 2-1, CH2 and C. So here alcohol, secondary alcohols to alkene, here double bond CH2. And now third one is ketone to alcohol. Ketone to alcohol. It is a reduction or oxidation? Reduction. I already mentioned AAA process. What it is? AAA. Alcohol oxidation. Aldehyde. Aldehyde oxidation. You will get the which one here? Acids. Primary alcohol, aldehyde. Secondary alcohol, ketones. Now, if you take here acid reduction, you will get the aldehyde. Aldehyde reduction, you will get the primary alcohol. Ketones reduction, you will get the secondary alcohol. You see, it is ketone, you are getting secondary alcohol. Means it is a reduction. Reduction means you can use sodium borohydrate or you can use lithium aluminum hydrate. Reducing agents you have to use. So this is the about questions from the NCERT test.